Okay, y'all, this is for Wednesday, 14.3 motion in 3 space. Read the daily problem given a derivative vector 0, 2, and 2t, and an initial condition at time 1, 4, 3, negative 5, find r of t. So pause the video, try to work that out, and then come back. Okay, I'm assuming you're back. Let's see, r of t. That's the indefinite integral of r prime of t, and r prime is 0 and 2 and 2t dt. If you find the antiderivatives, it's some constant d for 0 and then 2t and then t squared plus our constant vector. Then use the condition r of 1, which is let's see, let's add these two vectors together. dc1 2 times t, but t is 1, so 2 times 1 plus c2, and then 1 squared plus c3. This is equal to what we were given in the beginning, 4, 3, negative 5, 4, 3, negative 5. So we're left with d plus c1 is equal to 4. We're left with, let's see, 2 plus c2 is equal to 3. That tells us c2 is 1. We're left with 1 plus c3 is equal to negative 5. This tells us c3 is negative 6. And then if we rewrite our r of t from above, we get, well, I guess not all of it, but this part. There we go. We would get d plus c1 to be 4, but let's see. Oh, let's write that. D plus c1, then we would get 2t plus c2. So that's 2t plus 1 for c2. We would get t2 plus c3, t2 plus c3. c3 was negative 6, negative 6. And then we need all of d plus c1 to be 4. So our actual r of t recovered vector is 4, 2t plus 1, t squared minus 6. That works. And then that satisfies the condition. If we put in r of 1, we should get 4, 3, negative 5, and we would. Notice r of 1 is still 4, 3, negative 5. So there's our recovered r of t. Okay, moving on to position position, motion, and acceleration, velocity. Recall r prime of t is velocity, r double prime is velocity prime, that's acceleration. The magnitude of the derivative, that's the magnitude or length of velocity, that's the speed of an object. All of this given if r of t gives the position. So let's do two things. Let's move forward. If you're given r of t, find velocity and acceleration. So the derivative of r of t, that's our velocity. That would be the derivative of t squared e to the t and t e to the t. So this is 2t, it's e to the t, and then we need the product rule for t e to the t. Derivative of the first function t is 1 times the second function plus t times the derivative of e to the t is e to the t, and we need this at time 0. So velocity is 0. It's going to be 0 e to the 0. Let's see, e to the 0 plus 0, e to the 0. Velocity at time 0, 0, 1. This is 1 plus 0, so 1, check. Acceleration, that's going to be our second derivative, or our derivative of velocity. This is acceleration. Acceleration is the derivative here of 2t e to the t, 1 e to the t plus t e to the t. Derivative of 2t becomes 2. Derivative of e to the t becomes e to the t. Derivative of the last e to the t plus t e to the t is going to be this piece becomes e to the t. And then the derivative of t e to the t is what we had before. 1 e to the t plus t e to the t. All of this evaluated at 0. 2 e to the 0, e to the 0 plus 1 e to the 0 plus 0 e to the 0. What do we end up with? We end up with 2, 1, 1 plus 1 plus 0. It's 2, 1, 2. It's going to be 2, 1, 2. All right. The next part is dealing with a particle moving with initial position and initial velocity. And then we need to recover, based on our given acceleration, recover what the position was. Okay, so let's start moving from acceleration back to velocity, because if you have a derivative, then you can recover the previous function. So let's see, we're gonna look for velocity. That's going to be the indefinite integral of acceleration. Acceleration was cosine t. Ooh, I'm going to do cosine t like this. And let's see, I'm going to pause just 1 sec and then come back. Okay, I'm back. And okay, so we're looking for the indefinite integral of cosine t dt. That's going to be, oh, and it's, sorry, we have vector notation. So vector k. So this is the antiderivative of 0, 0, and cosine t. I'm going to leave the antiderivatives of 0 and 0 as particular constants out of this. I'm just going to write, the antiderivative of cosine is sine of t in the k position plus some constant vector, vector c. And what did we know about our initial condition for velocity? V of 0. So let's recover that. Constant velocity at 0 is sine of t plus our constant c, and this is equal to I minus j. And we're plugging in 0 for t. I need to go back. All right, so this is 0 k vector plus c is equal to I minus j. So c is equal to I minus j. That's the vector 1, -1, 0. So then let's update. We're going to update our v of t then. V of t, it was sine t of k, and then we're going to add c, and c is 1 and -1. So v of t, oh, I'm tired of this k notation. So I'm going to write sine of t in the k vector as 0, 0 sine of t plus that constant vector I minus j, 1, -1, 0. And we end up with v of t being 1, -1 sine of t. Get some more space here. 1, -1 sine of t. All right, so now to recover r, that's the antiderivative of 1, -1 sine t dt. Find your antiderivative. This is t minus t. Let's see, negative cosine of t plus our constant, and that's r of t. Now if we recover the constant. Recover C with our initial condition. What was our, let's see, R of 0 was 1, 0, 0. So R of 0, that's 1, 0, 0. And we're going to plug that into our R of t. So we have 1, 0, and cosine 0. So 1, 0, negative cosine 0 plus our constant. And so what's that? 1, 0, 0 is equal to 1, 0. Cosine 0 is 1, so negative 1 plus C1. I'm not going to write that. I'm just going to write RC. So C then is equal to this vector on the left, 1, 0, 0, minus this vector, if we move it over to the left side, 1, 0, negative 1. We're subtracting that. So our vector C is 1 minus 1, that's 0. 0 minus 0 is 0. 0 plus 1 is 1. That's our C. So then finally, to recover or update our position function. Position vector value function, R of t. Go back. R of t was t minus cosine t. T minus cosine t. And we're going to add the constant 0, 0, 1. So you could leave it like this. You could also put it together. That's t plus, put the pieces together. T and 0, that's just t. And then negative t and 0, that's negative t. And then the last one, negative cosine t and 1 is 1 minus cosine t. And then that should do it. Let's see. Yeah, the last thing I'll leave you with is I want to encourage you to read the example on, it's example 4 on page 888 about the baseball. It uses these ideas to move forward through derivatives or backwards through integration to answer questions about the path of a baseball. All right, y'all take care. Reach out if you need to, and I will be in touch.